Hey guys, welcome to Math Mastery Elite. Today we're going to discuss a concept from limits. We will now discuss how to use the L'Hospital's rule. Let us now understand what is the L'Hospital's rule. If limit x tends to a, f of x by g of x is in the form of either 0 by 0 or infinity by infinity, and f of x and g of x is differentiable, then limit x tends to a, f of x by g of x is equal to limit x tends to a, f dash of x by g of x. The most important thing in this statement is that the formation of the equation should be either in the form of 0 by 0 or infinity by infinity, and both f of x and g of x is differentiable. The f dash of x and g dash of x is the first derivative of the respective functions. Now let us understand this concept by solving a few questions. Let us look at the first question. Limit x tends to 0, sine 3x plus 1 minus cos 2x divided by x plus p tan x. The value of this limit is equal to 1. We are required to find the value of p. Now, let us look at the solution of the problem. Since this is in the 0 by 0 form, we will now apply the L'Hospital's rule. On applying the L'Hospital's rule, we get limit x tends to 0, 3 cos 3x plus 2 sin 2x divided by 1 plus p secant squared x. Now, on applying the value 0, we get 3 plus 2 multiplied by 0 divided by p into 1, which is 3 by 1 plus p, which is equal to 2. We get the value of p as 2. This is the solution of the problem, and let us look at the next question. The next question says that limit x tends to 0, a into e power x minus b into cos x plus c into e power minus x divided by x into sin x. The value of this limit is equal to 2, and we are required to find the value of a plus b plus c. Let us look at the solution of the problem. Since the denominator approaches to 0 and the limit is finite, the most important thing to note is that the limit is finite and the denominator is approaching to 0. So now we have to conclude that it is in the 0 by 0 form. So we can apply the L'Hospital's rule and we can get a finite value out of it. Now let's apply the limit to the numerator. We will get a into e power 0 minus b into cos 0 plus c into e power 0, which is equal to 0. Because we have proved that it is in the 0 by 0 form. We will now equal the numerator to 0. That is, a minus b plus c is equal to 0. That is the equation number 1. Next, we will apply the L'Hospital's rule, since it is in the 0 by 0 form. We will get limit x tends to 0, a e power x plus b sin x minus c into e power minus x divided by x into cos x plus sin x. Now, the denominator also approaches to 0 again. Now, we should now conclude that it is also in the 0 by 0 form, since the value of the limit is finite. Now, let us apply the limit to the numerator. We will get a into e power 0 plus b into sine 0 minus c into e power 0, which is a minus c is equal to 0. That is the equation number 2. And finally, let us apply the L'Hospital's rule. We will get limit x tends to 0, a e power x plus b cos x plus c into e power minus x divided by minus x into sin x plus cos x plus cos x. Right. Now, as we've seen here, the denominator doesn't approach to 0. That means this particular value is equal to 2. With this, the problem is over. We are actually solving the question in a reversed way. We got the answer first, and we are required to find the value of a plus b plus c. Since the denominator doesn't approach to 0, that this particular value, on applying 0, we will get 2. Now we get a plus b plus c divided by 2 is equal to 2. We will get a plus b plus c is equal to 4. If the question is something else like 2a plus b plus 3c, we can now get the answer by using 3 equations and 3 variables. Now let us look at a few important tips to solve any limit question. The first step is that simplify the given equation to its simplest form by either solving it algebraically or using some known standard limits. Now, if the L'Hospital's rule should be applied for more than 3 times, I highly recommend you to use the expansions which we derived from the Taylor series. Now, the next step is that I highly recommend you to use the L'Hospital's rule as the last resort, as the last approach, because oftentimes we see that by using L'Hospital's rule we get a different answer, and by using the above two approaches we get another answer. This is because the L'Hospital's rule is the approximate value, and the algebraic and the expansions is the exact value of the given equation. Now, oftentimes, even after we apply the L'Hospital's rule, we face one particular problem that the limit of a value doesn't approach to a single point. This is because the given function is is not differentiable. Now we have to check the discontinuity or the differentiability of the function while applying the L'Hospital's rule. This is all about how to use the L'Hospital's rule. Thank you and see you in the next video.